Colleen Reidelbach of Qubika.
You got my name right, it's Kunal Saxena. Yeah, PwC.
Ari Gorman, I guess that was the easy one.
My name is Jessie, and we're so happy to be here. I know we are stopping you guys getting lunch, but we'll make it quick and sweet so we can actually go get something to eat before the afternoon panels. And I used to be a college professor actually before when I went to startups. So this brings back a lot of sweet memories. I love to be a professor. It is our pleasure to have 3 panelists today. And I know you guys are all doing some really cool stuff, and I would like to make this panel more interactive. So, I'm really good on cold calling on people. I probably won't do that today. But if you have questions, absolutely interrupt us. We don't have to wait until the end to do a Q&A. Just if you have a burning question, just raise your hand, and one of the panelists can answer the question. So my first question is actually let's go back to the basics. Physical AI means different things to different people, I think. For example, I'm on the advisory board of a company called Artly. I consider that as a physical AI company because they make a coffee robot. The robot does latte art better than a barista could, and it's incredible. We always get like a line of people want to get a coffee from Coffee Robot when we at the conferences and things like that. So to me, that is my intro to physical AI. That's what I work on a regular basis. But I would love to hear what you all think physical AI is and how you interact with physical AI or projects you work on physical AI on a daily basis.
Well, I guess the technical definition is gapping from digital world to the real world. But it's really, I think, more about solving with 2025 technology, 1925 problems, inherited human problems with hard tech, with intelligence in the hard tech. So.
Yeah, I'll give you an easy one. Waymo, Tesla, they're both physical AI. They think like humans, they act like humans on the road. That's the easiest example that you see, especially in Austin, right? So that's if you don't know anything about physical AI, just look at those 2 models, and that's your framework.
Yeah, this is on. So I would classify physical AI similarly as anything where AI is touching the real world. It's been interesting, and we'll get into this as the conversation progresses, how quickly we've come to expect physical AI from our devices. And so even, any device that's sensing, processing, and decision-making can be classified as physical AI. So I bet a lot of you guys you may be wearing some right now.
Those are great questions. And when I was a professor, one thing I'd like to do is teaching by giving examples. I think that's the best way to learn. If you can associate a very abstract construct with a very concrete example, that usually sticks with you. So I would like to do the same today. I know that you all are doing something really cool. I know that Ari's company does robotics automation, and you also does computer vision. So would you mind anything you could share with the audience? A concrete example, you would consider that into physical AI?
Yeah, actually, we're working on a really cool project for drug diversion. It's a big problem in medical, where nurses, doctors have to dispose of drugs. And there is the system where there is the chain of custody, but it's not always followed. So using AI sensors to determine if the drug is what it's supposed to be and the quantity of it, and solving the problem that is big liability for hospitals.
So we're in Texas, so I'll give you a very local example. We get thunderstorms all across the state, right? We also get forest fires. So a common reason for forest fires and outages in thunderstorms is malfunctioning utility poles or pipelines, which are prone to disaster. One of the common things that utility and energy companies are doing is adding intelligence to the servers, the drones, the devices, so that the companies know which pole or which area is going to be offset, which is going to be disrupted by the storm, by the fire. So come the hardware, they're already prepared for disaster. They're already prepared with their technicians on standby, and they've done preventive maintenance to those hardware. So that's all getting automated, getting more intelligent. So we prevent such disasters. Like you put it into perspective, a wildfire can cost the company billions of dollars, and a maintenance will probably cost 500,000 or even less. So investing in AI for those kind of maintenance activities is super, it's adding a lot of value to the companies. So that's one area we're seeing, where I'm seeing from the energy and utilities industries where investments are taking shape.
So one example of a cool company that I have gotten to know over the last few years in Nashville is a company called XOI. They do eyeglass hardware and software for HVAC technicians and like field technicians in general. So the products they're building are the hardware to integrate the software to identify using computer vision what the technician in the field is seeing and get support both from proprietary information data that the company has, and also on-demand support for more experienced technicians. So that company has recently raised it.
Options generally come with challenges. There was challenges with the field technicians not knowing what the technology was, what the alerts were. There were challenges with the hardware. Some of the meters, some of the transformers were equipped with smart data, others were not. So basically the solution was not fully baked in. So it took them some time that, hey, let's revisit what we did and let's build a foundation for data that comes in later. Right now, the foundation that we have, or the software stack that we have, is not capable of getting the additional dimensions and give us the reports we need. So that's generally the challenge. People adopt a solution to address a specific problem without thinking, pros and pres and posts of that solution itself. So that's just one example that comes to mind.
I think early there was a lot of robotics companies that thought they can throw a lot of money at the problems and utilize a lot of engineering to solve, and you saw a lot of that. We can name quite a few examples. But I think what we have learned is that it's a lot easier to fail in the simulator work. So simulation. There's quite a few projects now that are not only are easy to access, but they have become kind of the norm. So I'm pretty sure a lot of the people here, they're familiar with robotics, so I'm sure a lot of them are working, but if you're not, I think that's a good place to start. The gazebos of the world and the ability to recreate and the ability to work within digital twins. That's where you want to fail, because you're going to fail, right? It takes a lot of learning. But that's really, if I could tell myself, if I could talk to my 10-year-old self, a 10-year-old ago self, is wait and simulate.
I feel like
I would just love to hear from a couple of my esteemed colleagues here on, kind of how they've seen this play out, because I think one of the big risk factors of innovating in this space is not understanding your end user well enough and not being able to picture what their life is like, what their job is like, kind of how they're incentivized, how they're kept safe, both physically and psychologically, because, you need buy-in from the people that are actually close to the technology. And so I'd be curious to hear from you guys as you're, building, physical AI solutions that are being put next to real people. Like, what have been some kind of situations that you've had to navigate through?
this is actually a really good segue for the next question I was gonna ask. Let's just kind of solve this or answer this big question altogether. It's really about ROI. And the other speaker last panel, she mentioned, right, like nowadays you can't just go to a VC and ask for 500 million just because you have a big dream. It doesn't work as well anymore, right? And then Ari just said you have to simulate because you want to reduce the cost of a failure to the lowest. sometimes we don't come back from a failure if it's very expensive, especially as a startup. So thank you, Colin, for kind of like asking, hey, like, how do we control, how do we, first of all, forecast what kind of failure, how much is a failure gonna cost us, and how do we prevent making those mistakes we can never come back from? Yeah.
I was actually interested in hearing more of the just very human, practical side of it.
That's
Of like
true.
what happens when a robot needs a human.
Well, so this might not be completely AI, but it's an example of when automation goes wrong. In Boston, in the baseball stadium, they deployed fully automated beer dispensing. And they had most of their right in their hands because there's workforce that gets displaced. And they had not worked through that. So it was a real world case where the client might be ready for automation, but your traditional and your workforce and real people's lives were affected. So you have to kind of go through those ethical issues too, right?
On a funny note, there was a common example that was shared, it made headlines in the news last year. There was a company that had automated its, code delivery mechanism, CI/CD. The AI was building the code fixes, it was deploying it, even QAing it. It did not, at one point, catch an error, and then, once the error got deployed, it tried to fix it. And in the process, it went into a critical loop and erased the entire code base. So the CEO of the product had to come and apologize to the client that, hey, this happened. They had disaster recovery and fail safes in place, so they were able to revert back to an older version, but that model had to be unplugged. So you have 90+% accuracy. It works 90+% of the time, but there is that a little chance of that thing going south, and then you just need to be prepared in those cases. So it can happen. I'm not saying it will.
It's not perfect, right? Nothing is perfect. AI is not perfect. Robots not perfect. So yeah, that's a lesson here. Okay, so let's talk about the ecosystem collaboration. I think that, as the last speaker said, nowadays, partnership is so important, right? So as you all work on your problems, what kind of partnerships are proving to be super effective in the problems you're working on?
So if we tie back the examples that we've discussed, right, we have to look at the end-to-end process of a solution. Our solution, like one product that we build, it feeds on data from another product or a solution. If we build partnerships across the value chain, we may not have to build the entire ecosystem of applications, but we may be better positioned to sell products and even convince people for adoption. That's just how I think about it.
Partnerships and ecosystem can mean a lot of different things. I have worked in a world where my clients approach me to solve kind of segments of their business problems. At Qubika, we offer engineering services, software, embedded firmware. We also do data and AI, cybersecurity. And so one of the ways that we're able to partner even with really advanced tech companies is just by serving as a scalable resource for them for supplementing some of their processes that are outside of their core business, so that they can focus on what they're really good at.
So going from a really high level, you have the Googles and the NVIDIAs of the world now partnering with robotics companies and creating foundational models, and that is what we are kind of waiting and working towards. But in the real world, when you work in the digital world, you take a lot of things for granted. Network is ubiquitous. But when you work in the physical world, that's not the case. So working with people that understand the ability and necessities to deploy solutions. So even as simple as network providers, right? Working with people that understand where the connectivity needs to be at, with edge providers, the resiliency. Unfortunately, none of those networks are self-healing. So there has to be the ability to move critical loads, workloads, in a way that, again, where there's gonna be some redundancy. So you have to work with people that understand how to work with those.
Yeah, so we'll come back to maybe a more big picture question. As you already said, you know, it's a very complex field to navigate. So it has regulatory problems, has ethical problems, and all sorts of problems. So let's just focus on, or let's talk about some of these problems that you guys have faced.
It goes back to a few things that we have discussed, right? One of the challenges to adoption is obviously the percentage, and people look for assurance that, hey, this is going to work. And in most cases, they fail to accept that this is a continuously learning model. It's going to get more data in the future. It's going to have different scenarios in the future. So the learning has to evolve, and that's the mindset we have to change with the clients, with our partners. That hey, if we give it the right water, it's going to produce the right fruit. So
I think it's, you know, you're always gonna have a risk reward calculation, and one of the things that's featured in the last panel discussion was how Austin has done a good job of fostering that, and so this is a phenomenon that my husband and I jokingly refer to as the blue dot red state phenomenon, where the city is very open to innovation as a whole, operating within a very business-friendly climate. And so there are a lot of advantages to that, and so I'd say that that's really key for keeping an eye on risk while still fostering innovation.
Yeah, so there's a lot of the same. What I would say is what we've seen from a project perspective, things that are successful is when there's a hybrid approach. You have teams that are working in AI and the tech, and you have other teams completely opposite that understand the core business and the complexity of compliance and ethics that are not, again, they work together, but you kind of have to create silos to be able to allow for the right people to do the right job. So yeah, most enterprises, they have to kind of go through that approach, right? You cannot worry about the core business and at the same time try to deliver a solution.
Great, yeah, love that. So let's end on more hopeful notes. I have one last question for each of the panelists. I know we dug deep into the issues, the problems, the failures, but I think, you know, it's good for people to hear, right? It's not all just rainbows and sunshines. And the last question for you guys is, what is a breakthrough or milestone you're watching for that could accelerate the mainstream adoption of physical AI? It's a pretty big question.
Also, from the technical perspective, it's definitely the foundational models, right? So instead of having to spend a lot of money and a lot of time training the machine to be able to utilize big models. So that is, again, that is going to be, again, going to the digital twin example. It's all about the right data. Somebody said that the internet now is like fossil fuel. And you cannot train a robot with fossil fuel, right? So being able to start using somebody else's experience and somebody else's training is going to be fundamental.
I'm looking forward to more innovation in the energy generation space, because the demand for data centers is rising. It's monumental. As of now, by 2030, all the plans that have been laid out for energy creation, electric or gas, they're going to max out on capacity for all the data center demand. So we're looking for more eco-friendly or more energy efficient data centers. That's where I'm going to look forward for the innovation center.
So it's really, I love spending time with my, in an environment where we're talking about a lot about what's on the bleeding edge and where the, kind of max innovation is happening. But one of the things I'm most excited about is the fat part of the bell curve, where most businesses are, where the middle market is in terms of their adoption of technology. There's so much value and efficiency to be captured, and that's what really excites me.
Thank you so much. I think